Hi students, I hope you'll be doing well. And in fact, today we are gonna go for a discussion of IGCSE Chemistry past paper. Basically, this is paper 62, alternating to practical. Okay, what we called it in other word like paper 6. And this is, the major 2020 series. Okay, so shall you get going? Okay, well, so I'm moving forward to discuss the question and answers here. Okay, so let's get started. The first one, question number 1. The hot copper to oxide react with hydrogen. The products are copper and steam. The apparatus used to react copper oxide with hydrogen is shown. Could you see this apparatus here? Okay, so this is the inlet of hydrogens, and here, the copper oxide gonna heat it over here. And then there is a U-tube, and then unreactive hydrogens are there. The colorless liquid is collected over here, and there is, the ice. These are called ice. Okay, so what they have asked about this diagrams, let's have a look. Student, could you see first 1A? Draw an arrow on the diagram to show where the apparatus used. The apparatus should be heated. Okay, so you have to find out in the diagram where the apparatus is meant for heating. Clear? So I'm going to show you here the apparatus, the diagram first. Okay, so there you need to draw the arrow mark. So it is clearly visualized by you that this copper oxide gonna heat over here. Okay, so just draw the arrow mark. So here the copper oxide is being heated. Clear? Now let me move on to the second questions. So while you are writing these answers, make sure this answer is gonna be number 1A. So just you have to write number 1A answer here. Okay. To B. So during the reaction of the color of copper oxide changes, state of color changes from dash to dash. Okay, so during the reaction of color of copper oxide changes, here what the copper oxide to be heated, copper oxide to be heated. For example, this is called copper oxide. It is to be heated, so it's going to form copper and obviously the oxygen gas, right? So what happens, when the copper oxide is being heated, so it's going to form a copper metal. So copper metal basically brown color, whereas the copper oxide will be black. That means it changes from black to brown. Changes from black to brown. Is this clear for all of you? So you can write here, the state of color change is from black to brown, because black is meant for copper oxide and this brown is basically copper metal. Understand? Okay, so let us move on to the next question. Identify the colorless liquid collected. So what is the colorless liquid collected here? Could you see the diagram? Yes, so here hydrogen gas is inlaid. Okay, and then from when this copper oxide is being heated, obviously here oxygen is present. Oxide is meant basically for oxygen, right? So finally, when this hydrogen and oxygen gas react together, it's gonna form water. Okay, so this water is to be collected over here. So this is the colorless liquid. This is gonna be water. So you need to write there. The answer will be water. Okay. So let's see. This is the answer. You have to write is just water or H2O. If you are conformed with the formula, then you can write even H2. Okay, fine. D, explain why the U-tube is in ice. Basically, why we use this U-tube. In this diagram, can you see? The diagram here, you can see this is U-tube. And here ice is present. What is the reason for that? Basically to cool this, the colorless liquid so that the steam condenses and became liquid. So for cooling purpose, to cool, so the steam condenses and became liquid. So for that, we're gonna use U2 over here. Clear? Is it clear for everyone? Okay. Now the next questions. First one, first bit. Okay. Now, the large amount of unreacted hydrogen should not be allowed to escape into laboratory. State why. They're talking about large amount of unreacted hydrogen should not be allowed to escape into the laboratory. State why. Because hydrogen basically can be used as a fuel. So in a less amount of heat energy if you provide, then this is gonna burn it. Okay, it's undergoes the combustions even in the less temperature. If less amount of heat is provided, then it's gonna go for the explosion. So that is why, as it is a flammable, so large amount of unreacted hydrogen gas should not be allowed. Understand? Okay, very good. So I'm just okay. So right answer, flammable. Okay, fine. So let's come on to second bit. Complete the diagram to show how the unreacted hydrogen could be collected and its volume measured. Label any apparatus that you draw here. Okay, you have to label. Already I have labeled it. Basically, gas can be collected and properly and accurately by means of gas syringe. So that the diagram here I have made it. So basically here we go to the colorless liquid collector here, and then unreactive gases can be collected by just attaching a gas syringe. This is called gas syringe. Okay, so that is why you need to draw this diagram of syringe. Syringe diagram is required. I hope it is clear. Okay. Next one. Question number 2. A student investigated the temperature change when magnesium ribbon react with dilute sulfuric acid. Okay, well, the first experiments were done. Sorry, 5 experiments were done. Experiment 1, using measuring cylinder, 20 cm3 of sulfuric acid were poured into a boiling tube. A thermometer was used to measure the initial temperature of the acid. 1 centimeter length of magnesium ribbon was added to the acid into the boiling tube. The acid and the magnesium ribbon in the boiling tube were stirred continuously using a thermometer. The highest temperature reached by the mixture was measured. The boiling tube was rinsed out with the distilled water. Then let me move on to the experiment 2. Experiment was repeated using a 2 cm length of magnesium ribbon instead of 1 cm length. Experimental same 3 cm with the same amount, same length. Experiment 4, repeatedly using 5 centimeter length of magnesium ribbon instead of 1 centimeter length. And experiment 4, 5 centimeter, experiment 5, 6 centimeter instead of 1 centimeter length. Okay, fine. So let's move on to the question. A, use the information in the description of experiments and the thermometer diagram to complete the table. So you're going to complete the table here. The thermometer diagram is given to you. Okay, so in fact, I have written over here the boxes filled with the length and initial temperature, highest temperature, and the amount of temperature increased. So the first experiment here, 1, 2, 3, 4, 5, the length of magnesium ribbon, okay, in terms of centimeters. So here already centimeter is written, so you are not suggested to write over here, so that will be considered to be wrong. Okay, so already here centimeter, so just write the number. Okay, 1 centimeter. Initial temperature, the thermometer diagram is here. Look at it's 20, 21, 22, 23. So the initial temperature is 23. Okay, so write down. And here the highest temperature thermometer diagram, you could see this is 20 scale look at it. Okay, it's 21, 22, 23, 24. Okay, because this is the 24. It's reading. Okay, so write just 24. Similarly, all of them just you need to write, because here you have thermometer diagram. Okay, so now here the experiment 2, the magnesium ribbon, the second centimeter, 2 centimeters, the thermometer diagrams, its reading is it's about 23, right? So this is 23, right? 23, here it's about 26, so write 26. And the third experiment here we have taken about how many, the amount of, I mean the magnesium ribbon in 3 centimeter, the temperature 23, then the highest temperature is about here 29. Similarly, when it was 5 centimeter cube length of magnesium ribbon, the temperature diagram, you look at it here, it's about 23, and the highest temperature is measured in this diagrams is about 36. Okay, and then the last experiment 5, which was taken, is about 6 centimeter cubed of magnesium ribbon. The temperature diagram same as it is 23, and the highest temperature measured is about 40. Okay, then you have to find the difference, the increase of temperature. So first experiment, you look at it, 23, the initial and final is 24. So 24 minus 23 is equal to 1. The temperature increase is 1, followed by 3 here, because it is just 26 minus 23. It will be equal to 3. Okay, term difference, 29 minus 23 is equal to 6. The difference of temperature increased. Okay, and 36 minus 23 is equal to 13. Okay, in this way, just you have to subtract and get the increased of temperature here. So finally, the fifth experiment where the temperature is increased, it's about the difference of 40 minus 23 is equal to 17. Now what you do, you got to know about the difference and increasing of temperature at the last box, right? So now let me read this question. B, Which experiment, 1, 2, 3, 4, or 5, was the temperature increase the highest? Could you see the last column? Here is the highest temperature measure is. The first experiment was 1, second 3, third 6, 4, 13, 50, 17. So maximum highest temperature, clear. So write the, so which experiment? Experiment 5, temperature is the largest. Okay, so let's move on to this. C. Add the suitable scale of the y-axis and plot the result from the experiment 1 to 5 on the grid. Draw a smooth line graph. Make sure that your line passes through the 0, 0 scale. Okay, 0, 0 points. So let's do. It's very easy to do it, right? So firstly, let me move on to the questions and what they asked, and accordingly we have to do it. Clear? So explain why the graph line must pass through 0, 0.0. Okay, make sure that this graph to be done based on this, this information, the table. The length of magnesium ribbon in terms of 1 centimeter, 2, 3, 5, 6, with the increasing of temperature. Okay, so that we have to take. The first experiment temperature was 1, second it was 3, third experiment 6, it increased 13 and 17. Okay, so accordingly you have to do the graph. So now 0 amount of magnesium ribbon used, then 0 amount of temperature increased. When there is a 1 centimeter cubed magnesium ribbon used, the temperature was, what is the temperature increased? We got it 1, obviously. So of course this square box, you make it this big line, so that means it is a 5, and then 10, 15, and 20. So you make it as per this square boxes, and this is basically the temperature increased. Okay, and then when it was 1 centimeter cubed of magnesium ribbon, so the temperature increase was, we got it 1, and there was 2 centimeter cubed. So what was that temperature increased? Here in the graph you have in table. Okay, so let me show you here once again. Okay, experiment 2, when the temperature, the magnesium ribbon was 2 centimeter cube, temperature increased was 3. Okay, first one 1, and then 3, 6, 13, and 17. These informations you have to use for the graph. Okay, 1, 3, 6, 13, and 17. Clear? So let us do it graph. Already I have done it, just for your understanding I'm making. Here 1 centimeter cube, that we got it 1, temperature increase 2, 3. When there was 3 centimeter cube of ribbon, then it was 7, right? And then when it was 5, then we got it, how much? It's just 13. Okay, when we used the 6 centimeter cube magnesium ribbon, we got it's about 17 temperature increase. So just you have to form a line here, the intersecting points. So in point of intersection to be drawn in a proper lines, and you will get this line over here. Okay, so this is the graph to be done as per the table given here. Okay, so the questions: explain why the graph line must pass through 0, 0.0, because there is no reactions with magnesium, right? When there was 0 magnesium, 0 temperature increase, that means there is no reaction at. Okay, it's easy. Well, next is E. From the graph, from your graph, deduce the temperature increase if experiment 1 is repeated using 4 centimeter length of magnesium ribbon. Okay, so they're talking about experiment 1 repeated using 4 centimeter cube of length magnesium is ribbon. You have to look at the graph in 4 centimeters, and then we have to find the grades, and the temperature. Okay, so here the 4 centimeters here already I have denoted. This is called about 4 centimeter cubed. So what you have to do, this you have to have a line, you intersect this line with the 4 centimeter until they get it touch here. Okay, and the same way after touching the lines, so of course you're gonna go for the horizontal line too towards the temperature scale. Okay, so now you have intersected 2 points, the vertical line in terms of the magnesium ribbons, and it intersected here in the line graph, and this you have line it with a horizontal that you can give you, I mean that will give you the temperature. So it's about coming here about 9 degrees Celsius, right, with the grid of 4 centimeter cubed of magnesium ribbon. So the temperature you just need to write down. What we got it about 9. So when the magnesium ribbon was 4 centimeter cube, temperature could be 9 Celsius. So make sure that you have to write the unit as well. So 9 degrees Celsius, because students they tend to forget the unit. So that is easy to lose marks. Make sure that you're gonna write the unit as well. Okay, fine. So let me move on to the F. First bit. Why would carry out the experiment in the polystyrene cup rather than the boiling tube improve the accuracy of the result? Questions hopefully you understood. So why are we going to use the polystyrene cup rather than boiling tube? So basically, polystyrene cup is very famous for a good insulator. Okay, so if you take over here, the heat loss will be very less. The heat will be not lost much. Okay, so that you can just write over here, polystyrene is a better insulator. You will get the accuracy of the temperatures. Okay, the second bit. Sketch on grids the graph you would expect if the experiment was repeated using polystyrene cup instead of boiling tube. So what happens? So as it's the polystyrene cup acts like an insulator, so there will be no heat lost, so temperature can increase, right? So temperature can move on to the surrounding. So we just write the grid here. It's the increasing of temperature. Okay, so what you have to sketch on grid the graph you would expect. So you have to sketch on the graph about it. If the experiment was repeated using the polystyrene cup, then temperature will increase. So if temperature increasing graph, you have to show in that main graph over here. Okay, so what you do, as we came to know the polystyrene cup prevent the heat loss, right? So that there is an increasing of temperature. If there is an increasing temperature, now what is the effect of this graph? So you will get the, obviously the main graph is here. This is number 1, for example. This is the main one. So above the main graph, you will be getting the grid. Okay, the same way, just you draw like this. Okay, it's very accurate, it's fine. I'm drawing in my mouse, so it's getting like this. Okay, so for your understanding, you make sure that it's going to be in a proper way. Okay, so maybe let me try once again. Okay, I'm trying in my mouse. Okay, just make sure that as temperature increase, the graph will be here just above the main graph. So you can draw like this. Okay, this will be the grid for the second when the temperature is increased. Okay, this was the first main one. Okay, just it will be above. Okay, so for that you can get the mark. Next, here we have question number G. The volume of dilute sulfuric acid could be measured with a 20 centimeter cubed of pipette. First bit, state one advantages using pipette. rather than measuring cylinder. Okay, so as we know that pipette gives you more accuracy, right? So it is more accurate than measuring flask or measuring cylinder. Okay, just write down more accurate. Second, one disadvantage using pipette rather than the measuring cylinder. Obviously, measuring cylinder is very convenient, very easy to quickly you can measure it. But you know, pipette is complex or complicated, you feel. So it will be slower. This is the disadvantages. So it's actually uh, slower. So just write the answer slower. Okay, fine. This is question number 3. Two solid L and M. Okay, solid L and M were analyzed. Solid L was containing chromium chloride. Chromium 3 chloride is basically chromium chloride. Okay, tested were done on each solid. Test on solid L. Complete the expected observations. Solid L was dissolved in distilled water to produce solution L. Solution L was divided into 4% in 3 test tube and boiling tube. Clear? A. To first portion of the solution L in the boiling tube, about 1 centimeter depth of hydrochloric acid was added. Gently, a strip filter paper was dipped in acidified potassium permanganate solution and held at the mouth of the boiling tube. So basically, potassium manganate solution is used for a test for reducing agent. Reducing agent. Okay, so what? A strip of filter paper was dipped into acidified potassium permanganate solution and held at the mouth of the boiling tubes. So basically here we have, the dilute hydrochloric acid, and they're talking about the chromium chloride. When this chromium chloride react with this dilute hydrochloric acid, basically what you got? Chromium hydroxide, obviously, right? So that's not, it's even a reducing agents, so that you're gonna get no changes happen. Okay, so if there is a compound is related to the reducing agents, the color change takes place from purple to colorless if there is reducing agent. Okay, so that is why there will be no change takes place. Okay, next one is to the second portion of L solution sodium hydroxide. It was added slowly until it was excess and no further changes were seen. So what is the observations? They're talking about chromium 3 chloride. Okay, so remember the second portion of solution L, aqueous sodium hydroxide. This aqueous sodium hydroxide we use for the test of cation. Test for cation. Okay, means basically the metal ions. Okay, so what happens as there is a chromium metal? So here we have chromium 3 plus, Cr3 plus. You know that chromium 3 plus gives green precipitate, right? Green colors. When you add the sodium hydroxide, either you add the few drops and even in excess also, it produces the green precipitate and it dissolves. So you just write over here, the green precipitate formed and then dissolve producing green solution if you add excess of sodium hydroxide as well. Okay, so you can remember directly, or you just memorize that also, it's fine. Chromium 3 plus and gives you the green precipitate. Okay, PP2. Next one. The third person of solution L, aqueous ammonia, was added slowly until it was an excess and no further changes were seen. What is the observations? There we used sodium hydroxide. Now here we are talking about ammonia. Okay, Ammonia also it used to test for cation. Okay, so what happens, when you add slowly a few drops of ammonia to the chromium containing, here we have chromium chloride, right? Cr. Okay, there is a chromium metal. So what happens, you will get the gray-green precipitate. But when you add excess, the precipitate does not dissolve. Understand? So basically, if you add excess amount of ammonia, then the precipitate does not dissolve. So what is the color of the precipitate? Green precipitate. Okay, is it clear? Fine, I will move to this D. To the fourth portion of solution L, about 1 centimeter depth of the dilute nitric acid was added, followed by 1 centimeter depth of the aqueous silver nitrate. Okay, so what will be the observations? Make sure that they're talking about the compounds, just initially we came to know there were chromium chloride. Okay, chromium 3 chloride was there. So what will you get it? So basically this dilute nitric acid and silver nitrate are used to determine the presence of anion. Okay, so basically for halide ions, we use dilute nitric acid and silver nitrate together. Okay, halide ions are, it is like chloride, bromide, and iodide. If you get white precipitate, then that should be chloride, and bromide gives cream precipitate after adding this couple of compounds, and the iodide gives yellow precipitate when you add silver nitrate and dilute nitric acid. Okay, so you can memorize this also. So what will be the answer here? Which precipitate will you get it? When you add dilute nitric acid followed by silver nitrate, it is HNO3, and this is silver nitrate, AgNO3. Okay, so after addition of this couple of chemicals, you will get it white precipitate, because in this compound chlorine is present, right? So it will become silver chloride, AgCl. The color of silver chloride is white precipitate. So let me move on to the next part. Test on solid M. What they talk about: tests were done and the following observations made. Test on solid M. Test 1, flame test. When you do flame test, the observations yellow frame. So basically, when you are actually doing the flame test, the metal sodium will give you yellow color. Remember it. Okay, test 2, about 10 centimeter cubed of dilute nitric acid was added to this solid M. Any gas produced was tested. We use lime water for the test of carbon dioxide gas. Okay, that means here it turns milky, then you can say there will be carbon dioxide gas. So basically this here we have carbonate and understand. So we got it here, sodium plus, it gives yellow, and here we have carbonate. Clear? So now let me move on to the third test. Test 3, about 1 cm depth of aqueous barium nitrate was added to the solution formed by the adding dilute nitric acid to solid M in test 2. Okay, so to test for barium sulfate, I mean for white precipitate, for getting barium sulfate. Okay, as it's not forming, so there is not barium sulfate formed. Okay, so there is no change. There is not the presence of barium sulfate. So let's see what they asked. E, identify solid M. So here we got it already. I told clearly. Here we have flame test, we got it is a sodium metal Na plus, and test 2 we got it, what is that, carbonate 2 minus, directly just write it Na plus, and CO3 also you can write, or just write sodium carbonate formula to be Na2CO3. Okay, Na2CO, solid M is present. Okay. Okay, then let me move on to the next question. Okay, next one. This is the last question, I guess. Let's see. Number 4. Many windows cleaning products contain aqueous ammonia. Aqueous ammonia is an alkali that reacts with dilute acids. Plan an investigation to find which of the two window cleaning solids contain the most concentrated aqueous ammonia. Include your plan. What you have to include, the method you use, and then the second is how your result will be used to determine which window cleaning product contain the most concentrated aqueous ammonia. Then you are provided with an aqueous solution of two window cleaning products, dilute hydrochloric acid, a non-concentration, and then common laboratory. Okay, these are the provided equipments and the processes. Just you have to plan it and investigate. So this question, okay, it's easy. The question's relevant for, just remember it. They're talking about an alkali and they're talking about acids. So alkali acids, when they react together, so you're gonna get a salt that's basically a titrations. Okay, it is a famous chemical reactions we studied in IGCSE. So how do you do for the titrations? It is well known to you. Just let us do uh, the stepwise. And moreover here, I'll tell you that it's going to be a 6 mark. So make sure that you have to write it's about 8 to 9 points, so that if one or two answers, if not part of the marking scheme, so you may not lose the marks. Okay, that is why. So always remember, while writing these 6 mark questions, try to include about 8 to 9 points. So basically, as they are talking about the alkali and the acids, so we do for titrations, what we do, we usually take the burette, right? Okay, let's say this is a burette. Okay, this is the tap, and here just below it there is a conical flask. Okay, so by means of pipette you have to measure the things, and then so here it's about burette. What we have to take, you can take a hydrochloric acid or any cleaning product here in terms of ammonia solution, you can take it. And moreover here we need to take the indicators in terms of methyl orange or phenolphthalein. That's up to you. Okay, so that's going to be the titration process. And here basically what we do is titrations is meant for the unknown volume to be measured if you given the known volume, or unknown concentration also to be found out if you know the known concentration. One known concentration will be there and you are going to find the unknown concentrations. Okay, so this process, this is the procedure how we use. Actually, we here you can take it in the conical flask by measuring the pipette. Okay, and then drop wise you need to mix it. The hydrochloric acid you just drop wise you leave it after addition of these indicators. Once there is a change of colors, then you just find out that is the endpoint. So how do you investigate this? So right in the stepwise, put two window cleaning product in separate beaker. Okay, and add dilute hydrochloric acid from the burette. And this third step, add methyl orange or phenolphthalein indicators and stop the burette once there is a color change. So when there is a color change, obviously you have to stop it, and then the further investigations. Use the same amount of cleaner, for example 50 centimeter cubed. Use a pipette to measure its volume. Okay, and then record the volume of acid added from the burette from each cleaning products, right? And the final step, the product that is used bigger volume is the more concentrated. Okay, this is the way, this is the procedure you're supposed to do for uric acids. Okay, very simple methods. I hope you got it. Thank you and have a good day.